You're listening to Masonry Principles, your guide to building better buildings, with hosts Amanda Bedian and Phil Leden. Well, thanks for listening to Masonry Principles. Today we've got Brent Jacobs. He is with DuPont Specialty Products, formerly known as Dow. Did I get that right, Brent?
Yep, you got it.
Fantastic. Brent is here to discuss what DuPont's about and the materials and then the different topics that they cover within their company. And we're going to get things started. I guess we'll just jump right into it.
Sounds great.
In terms of some of DuPont's products, Brent, what are kind of the differences with your insulation products, I guess, to start with, when we're talking about cavity wall construction, kind of some benefits of the different products you guys make?
Right. So the products that we make, there's many different types of insulation, but primarily our two main product lines, let's say, are polyiso foams or polyisocyanurates. So it's a two-component material that's made at a plant. It's in a line process. The other lines are extruded polystyrene, so that's an extruded. It's a plastic foam that's made up. They add some blowing agent, and it pretty much extrudes out rigid foam board. So we have extruded polystyrene and our polyiso boards. So our extruded polystyrenes, styrofoam is a trade name. It's been around about 80 years. There's a lot of history there. Our polyisocyanurates are a little different. They're not, the history is not as long. We acquired a company called Celotex about 20 years ago, and it's a foam board that's made between two foil facers. A lot of those polyiso foams are typically not ours, but we have foil face. There's non-foil face that are used in a lot of commercial roofing applications. But the product lines we have with our polyiso foams are primarily used in wall systems. So probably the biggest products that we do use in the cavity wall applications are our extruded polystyrenes, like styrofoam, because it has a potential to be a very wet, moist area, and due to the closed cell design of the foam, think of it as a bunch of plastic bubbles. It performs very well in potentially moist environments.
Do you see architects kind of specifying them incorrectly a lot? Like maybe they're requiring roofing insulations in cavities? Do you see that happening?
We have seen some of that. So with the extruded polystyrenes, you can make all different compressive strengths, and they kind of fit according to ASTM C578 to fit into different buckets based primarily off of compressive strength. So a lot of the higher compressive strength products can be for roofing applications to where you might have pedestals or something or pavers that need to be supported or under slab. So sometimes you do see those specced in wall systems, and it happens. We try to correct that when it happens because there's a price differential, and that compressive strength doesn't really provide a lot of benefit to the wall system itself to where it would really make a difference. So it's kind of to the end consumer not an efficient use of money.
When they're putting that insulation in that cavity and they're using those foam joints that they spray out in both the head and the bed joints, have those been tested kind of as a vapor barrier and an air barrier?
Yes, yes. So the whole wall system actually has been tested as an air vapor barrier, and then the foam that's used. So you're talking about an ultra wall system that we use a type of styrofoam. We place it between the ladder ties of a masonry wall for multi-weight masonry construction, and then they'll use Great Stuff Pro in between the board joints in order to seal that off, and that gives you your air water vapor barrier. And then that foam that's used in the board joints, that Great Stuff, is actually a closed cell foam.
Gotcha. And in terms of NFPA 285, I know Chapter 26 of the IBC, if we don't have an airspace, we don't have to comply with NFPA 285. Or if we do have an airspace with a maximum of 1 inch, we don't have to comply with NFPA 285. But do you guys have details that are available that do comply with NFPA 285 for your head and your jam details?
Yeah, yeah, and the good thing, especially about masonry construction, is because it's CMU blocks non-combustible. It allows for a lot of flexibility. So, it's tougher with like a steel stud style construction, to where you have to worry about more. Even though the steel stud's not combustible, it doesn't provide the thermal break from the inside to the outside when they're doing the 285 tests. So there's a little less flexibility with cladding types and the like. But yeah, to answer your original question, yeah, we do have details on our websites that go over that. We have a whole detail package that was rolled out a couple of years ago. It's pretty cool. They went through and put them all into a nice package for our ultra wall system for masonry walls.
So as far as resources available, where do you just send people to the website to get some technical information, or is there another spot people can look for to get a little bit more in depth with what you offer?
Yeah, so I mean, typically, like for myself, I try to be as much as possible the focal point for architects in case there's ever any questions. But yeah, we'll try to point people to our website, including away from the architects, the contractors, the end users a lot of times because we have there's always questions, especially something that's if it's something they don't do every day or stuff like that. It's like I said, they'll have questions. So we have a nice FAQ set up on our website and it's under building.dupont.com, and then there's a tab, your resources tab, and then answer center. It's nice because that can kind of point them in that direction, and then all the other resources are on the website. Sometimes there's a lot of changes going on ever since the Dow DuPont changeover, so there's changes with the website layout, but I feel like we're getting to a real good spot now to where everything's kind of accessible.
Awesome. Now I'm in New York. Who is the rep for New York State?
So New York State's kind of split up into a couple areas, but the main rep for like Metro New York would be his name's Dennis Italia, and I can pass his contact information around if needed. But he's been around a while. He's got a lot of experience. I actually reach out to him quite a bit for just general knowledge questions because being more green in the role than somebody like that, you got to soak up what people have.
So, I mean, we talked about kind of these multi-weight systems, but a big portion of the market we've really lost from the masonry industry is that single weight market. And we've been really busting our asses trying to get that market back and doing a lot of education on energy, things like that. Are there any products or, I guess, strategies that DuPont has for complying with the energy code, especially for single weight masonry walls?
Yeah, we've been working, I mean, as you know, Phil, the generic wall design committee of the Masonry Institute of Michigan's been working really hard at trying to help people navigate and meeting the energy code with these single wide systems. So, from a DuPont standpoint, we have our Thermax product, so that's our polyiso foam, is approved for being left exposed in these types of situations. So, and what the Masonry Institute of Michigan, you guys have determined or worked towards getting a solution that's very easily digestible by the end consumer, is you don't have to have foam all the way or any type of insulation all the way from the floor to the roof wall juncture. So that's where it's kind of neat what you guys have came up with, where you can just use a type of polyiso foam, leave it exposed to the interior, but you don't have to have, for example, the bottom 8 feet. So that can all still be block, which obviously block is more durable than foam. So it's great for wear if it's a warehouse.
Yeah, I mean, especially with warehouses, I mean, you can never trust a forklift driver. So, I mean, it's really nice if we can leave that bottom 6 or 8 foot
Yeah.
exposed. And I think polyiso, I mean, that's perfect. It's a great application for it. I mean, it can be left exposed. We
Yep.
can meet the energy code that way. Real nice solution.
Yeah, and it seems to be, a lot of that what used to be all mostly single wide is, there's a lot. I mean, you could probably comment on this more. There's more steel buildings that you're seeing now. Is that correct?
Yeah, definitely. I mean, the steel and the wood industry have definitely been kind of capitalizing on that, and we're just seeing that single width, that market just kind of diminish. And I think a lot of it comes down to education with the energy code. And I think DuPont and institutes like the Upstate Masonry Institute and MIM, I think we can really advocate for how these wall systems can meet the energy code and all other code requirements and be cost competitive.
Yeah, I think it's a great application in those standpoints because, I mean, you've seen, or in myself, my background with residential, light commercial construction, you talk about the forklift stuff, and it's crazy what you'll see people run into. It is amazing what people can do with forklifts. So if you can use something pretty durable like a CMU block, like that's seems to be a great solution. You know.
And even from a sustainability standpoint, I mean, we talked in one of our other podcasts with Tina Basic, and I mean, those things like the gypsum board and insulation, I mean, that have that wear and tear. If you're replacing them constantly, you're trying to think about your building holistically from a sustainability standpoint. I mean, those items, they're getting replaced all the time, just kind of goes against that whole sustainability aspect.
Yeah, exactly. And that's where it's, Phil, we talked about this the other day on it, and just the whole sustainability thing, I'm sure you talk about in other podcasts, needs to be looked at more holistically than just this building saves this much energy a year and that's it. Because there's just the picture needs to be seen from a bigger angle to know how it really performs. as far as the energy used to build the material, to build the materials, to ship the materials, to install them, to maintain, and it's just there's so much more to it.
Definitely. In terms of, I guess, New York and Michigan, I mean, we both have winter and summer, obviously, with our climate zones. And so, from a dew point analysis, does Dow still run dew point analysis free for designers?
Yeah. We have a technical service team that will run that. My background is originally in Dow, and then DuPont is in the technical service side. So I've used to run dew points all the time. So I would rather be the hands-on person for people in my area. What they can, if a designer architect has any questions, they can reach out to their local DuPont rep, and they can get that done for them. So it's kind of neat. It's just based on ASHRAE Fundamentals Handbook. I have a coworker that actually is an architect that's been around for many years. And he's like, when he started out, he went to University of Michigan. So we used to have to calculate these all by hand, and each one would take hours. You just need to know the thickness, the permeability, and the R value of the material of your wall system, and you can calculate it. But it's now with the tool, it's quick and easy. So it's nice, and it's a nice service that we can have to kind of see if there's any concern with the wall design. So it's nice to have.
And with a block backup, I mean, we're usually not seeing as many issues with dew point. When I look at some of these metal stud buildings and, going more panelized with metal studs, it seems like in the past we've looked at in the summer months, we're seeing a lot more dew point issues, even with that vapor barrier, where we're getting a dew point occurring basically in that stud space.
Mm-hmm.
Is that the case? I mean, are we not having as many issues with the masonry dew points?
So you don't see as much, like I said, with the masonry side. I think a lot of it is block and brick are pretty permeable, so that helps from a vapor trapping standpoint. And then, I mean, the biggest issue with like a steel stud gypboard design is, especially so I'm in Michigan, if you look at cold winter months and you have that cold condensing surface on the interior side of the gypsum, and then you have humid inside air hitting that, then that's going to condense on there. Similar to your soda can sitting outside in the middle of summer. If you have a koozie on, it doesn't happen. But the can itself, the moisture and air will condense on the outside and make it look like the can's sweating. The same thing happens with your wall.
In terms of, I guess, vapor barriers, I mean, are there different permeabilities? And I guess what type of products are available? And are there different permeability ratings and things like that?
As far as interior or exterior, are you talking? Because I know there's different classifications of vapor barrier that you'll see depending on and they're class one, two, three, depending on the permeability.
Hmm.
So from a DuPont standpoint, what we have for, aside from our rigid foam boards, and obviously you can guess like our Thermax board that's got foil face, like that's pretty much zero perms because you can't get moisture through foil. But like from our wrap products, like many people commonly know Tyvek, and then coming from the Dow side, we had Dow Weathermate plus House Wrap. Those are all permeabilities anywhere from 5 to 45. The Tyvek product has a higher perm, and then the Dow Weathermate has a lower perm. And they each have their pros and cons depending on what the application is.
Gotcha. So if we did have a metal stud backup with a brick veneer, I guess what kind of strategies in Michigan and in New York could we come up with to kind of mitigate those dew point issues?
The biggest thing you can do, and New York is pretty similar in climate to Michigan, so the science doesn't change from one to the other. But the biggest thing you can do is have a layer of continuous insulation, because that acts like the koozie on your soda can. You know, all of a sudden the outside of your koozie doesn't sweat when you have it, and it's especially important in steel stud construction because steel is so conductive. So you lose so much of your effective R value because of the wall. So if you put, let's say you put an R21 bat between 2x6 or 6-inch steel studs, you're losing a good chunk of that R. If you can keep that to the outside, not only do you make the wall more efficient, you also avoid hitting that cool condensing surface. So if that moist air gets into the wall cavity and all of a sudden the inside of that gypsum is a little bit warmer because you insulated the outside of the building with the layer of continuous insulation, you have less of a problem with condensation. And condensation isn't the issue, it's what moisture does over time, what it does to gypsum or air quality with potential for mold and those kind of issues.
I guess in terms of the market, I mean, are people still using bat between the studs, or are you seeing more people move to more of a continuous insulation on the outside?
Oh, yeah. Well, still very common to see bats. I mean, I speak from a Michigan standpoint. When I see steel stud construction, it's still pretty very common to see bats. The code's got different paths to compliance. And there's the R value charts, or there's the U value chart, which brings into account the whole wall. So not just the R value of the cavity. So it may say like you can get away with R13 cavity, or the whole wall has to have a certain U value in order to get it. So there's definitely ways to get around that as far as the continuous insulation requirement that may show up in the energy part of the code. You still see it quite a bit. And the biggest thing too is it's kind of the incumbent with lots of things. There's certain parts of many industries that are resistant to change for good and bad. I mean, to be honest, somebody that's been around a long time, they've been told lots of things are the next best thing, right? So you're always very skeptical. And if something works in their mind, then they're going to be reluctant to any type of change. So I think that's the biggest thing. And there's still a lot of specs out there that have been around for years and years, and they don't change.
And I thought I remembered reading about your Thermax system that it helped to mitigate some of that thermal bridging. Because, like you had mentioned, if we have our steel studs at 16 inches on center, I mean, we have that thermal break at 16 inches on center that just it takes such a toll on that R value of our wall system.
Yep.
But I think, don't you have a spray Thermax system that helps address some of those issues?
So we have a Thermax wall system, yeah, and it's got a couple different parts to the system, I guess. So we have different grades of our Thermax polyiso foam. The difference is the facer thickness. And then the facer thickness kind of is going to impact the durability of the foam, and thus from our end, it impacts the warranty that we have with the system. But essentially, it goes back to the same thing as far as putting a koozie on the outside of the building versus putting it all in the cavity. You're just trying to make sure that you are effectively insulating the whole outside and not just between the highly conductive studs. I've heard some of my coworkers say sometimes you don't want to eat your sweater, right? You wouldn't eat your sweater and put it between your ribs, right? You'd want to wear the sweater over you to keep you warm. So it kind of follows along the same principles in a sense. And then that uses our Thermax foam on the outside of steel studs, and then spray foam can or cannot be used. There isn't required to be part of it, but that is part of the system. It does help. It's the belt and suspenders method where you're getting the extra air sealing from doing that. And then we have different types of board joint treatment options with that system. So there's a couple different types of liquid armor that we have. That's a fluid applied joint compound. Historically, we used all tapes until we kind of came out with these awesome fluid applied products, and they're just so robust. It's nice to see something that we know will stand up.
From a cost perspective, is there a big difference between those fluid applied products and a tape?
Well, yes and no. So the tape is cheaper, but the tape can also take a while. And the issue that we had found as a company, and actually our Thermax wall system, we don't warrant tape joints anymore, because the issue that we kind of came across was never really knew how the tape was installed. So if it's wet, if it's rainy, if it's too cold, you're never there when they're installing it. And what we found with the fluid applied, so we have two different liquid armor products. Liquid Armor CM is it's like kind of like a thick paint, so that's a sprayable product, and that comes in 5-gallon buckets. It can be sprayed on. And Liquid Armor LT, which is a silicone based product, can be used more on low temps. Both of those, they're just very robust, and it can stand up to more real life situations that you come across on job sites, as far as installation and then post installation wear and tear until the cladding's actually put on. I just kind of learned from experience and then came up with the fluid applied system. It's nice to have a good solution for something that we know we trust and we know we can trust.
Do you guys make any sprayed insulations that go like in the cores of block for a single wide system, Brent?
Along with our rigid foam boards, our extruded polystyrene, our polyiso foam boards, we do have the Great Stuff line of products, which are single component foams. And then we have a froth pack line of products. They're professional use 2-component low pressure kits. But none of those are for use in cavities. To answer your question, we don't manufacture anything specifically for use in masonry walls. So it seems like maybe you can comment more on what you historically see through that. It's like vermiculites and like those types of loose fill materials. Is that what you see for the most part, Phil?
Yeah, we're still seeing a lot of the loose fill with the vermiculator perlite materials, but some contractors are moving to open cell or closed cell sprayed in place foams in the cavity.
Like a pour in place type of thing they can kind of like inject in a sense.
It's more, yeah, an injectable type foam, and we
Yep.
usually see it used in conjunction with something else. Because just in our climate zones in New York and in Michigan, just using vermiculite perlite or a sprayed in place, I mean, it's just not enough to get us with a low enough U factor that we comply with the energy code. I mean, it helps. I mean, it helps limit how much insulation we do need to put
Yep.
on the inside face.
So then with those blocks, I mean, is that just standard blocks for the most part that they're doing that with, or?
Typically, yeah. If we move to more of like a high performance unit, like maybe like a high R, a high RH, or an Omni Block or NRG, one of those type of units, usually those comply with the energy code prescriptively,
Okay.
and so we don't need to do anything else.
Yeah, it's kind of neat some of the technology with that. It's not that complex, but it's kind of it's just it's interesting when you think about it. You're like, oh, that makes sense with some of those blocks. It's kind of cool.
Yeah, masonry's come a long way since the pyramids, right?
Yeah, that's true. Although they're still standing, so not much from that. It's interesting, and the nice thing with masonry is it's simpler than it is with steel stud or more combustible construction.
Well, thank you so much, Brent, for sharing all the information that you have. And like you said, if anybody has any questions, they can reach out to Brent or go over, check out their website to see all the different resources available through DuPont. And if you liked what we had to say today, then be sure to share our episode. You can find this episode and other on Apple Podcasts, Google Podcasts, and Spotify. Thanks for joining us. Bye. Thank you for listening to this episode of Masonry Principles. To continue the conversation, be sure to reach out to us by visiting masonryprinciples.com.